Hello. My name is Piotr Białczak. I work at Polish National CSERT, CERT Polska. It's a part of NASK. My colleague Michał works at NASK. It's a research institute in Poland. NASK runs .pl DNS registry, the Polish one. Also hosts CERT Polska, and CERT Polska is as mentioned before, is our national CSERT, and we try to secure Polish internet. So in 2024, we have registered in Poland 98,000 incidents regarding phishing and fraud. It was 95% of all of incidents. So you can say that in Poland, the phishing and fraud are the most common threats. So what we are doing about it? Firstly, we try to block domains at .pl registry level. Of course, you have to have a proof whether there is a phishing there. You can also try to block domains at resolver level. Those domains which it's effective for those domains which are not at .pl TLD. That's the work we are doing. Of course, we have a proof for every such a domain. Also, you can block domains at resolvers, of course, when they are likely malicious, but that's not the path we are going into. In 2022, in March 2022, we have launched a country-level DNS firewall. It provides continuous feed of malicious domains. We call it a warning list. It's manually verified by 2 human analysts. We updated it 24/7. Anyone can check it. The thing is that the list is voluntary. We only publish those domains which we believe are malicious. However, the list is applied by all big telcos in Poland. In the figure, you can see the number of domains we put on the warning list. As I said before, the numbers are for all TLDs, not only .pl. So the numbers are rising. You can see a big increase this year on the right-hand side. So we have turned in some new detection methods. So a big increase. So a lot of domains and a big problem in Poland. So how you can identify malicious domains? Firstly, as a Polish national CSERT, users can report URLs to us. For example, using our website, but also they can send us messages, SMS messages to a free number. Then you can hunt domains using certificate transparency logs, passive DNS, registry data, etc. All those things. Of course, we are living in the age of machine learning and artificial intelligence. So you can also use machine learning technologies to power your detections. So that is the main part of our talk today. The work done here is a part of DNS for EU project. Here are some buzzwords from European Commission call. The main goals of DNS for EU project is to create a wholly operated DNS resolver at European level, which puts security and privacy as the main focus. The service is live. You can check it up, but maybe after our talk, not now. So stay with me. First part. Looking into .pl registry is the data we get from our registry as NASK. So we try to detect phishing domains shortly after they are registered at our registry level. We use the registry data to do it, like all the things where input our contact information, the registrant, the register information, all those things. So here we focus on campaigns targeting Polish internet users, and we have created a system. We call it bad domains with ML, like machine learning, obviously. So after we get data from the registry shortly after registration, then we combine it with a feed from the warning list to show the model how phishing domains look, and then we train the model, and you can make a prediction whether a newly registered domain is phishing or not. So we have started research in like 2024. As you can see at the detection level in the figure, the numbers were high, but in one moment the numbers dropped. So drop was like from a couple of domains per day to a couple of domains per week. So that was a problem for us. So we started to look into it. Firstly, all the cyber criminals stopped to use .pl domain. Well, it's good for our domain. It's good for NASC because .pl is a safe domain, safe TLD. So if you want to, please use it. But the low-hanging fruits are there aren't any at this moment. So when you predict the domain, it's not enough. You have to get the phishing payload on some subdomains. So here is an example. A domain, it's ID 3283.pl. If you access it, it's like no information, no phishing payload. If you guess the subdomain and get active URL, then you can get the actual phishing payload. It's a phishing for a ticket selling company. As you can see at subdomain alebilet.id3283.pl. The payload is there. So if you have the URL, if you have the subdomain, then you can get the domain. Also, if you can hunt for some queries, then you can get some data. So we started to address the problems, with the problem with a low number of detections. We started to tweak the model, and it ended with doubling the number of detections. However, still, only 30% of domains which are on the warning list, .pl domains on the warning list, are detected with our method. You can ask, is it worthy to given all the effort we have given? So the first thing is that we believe that there is a value in our system. About 20% of detected domains are not seen by other methods we use to detect phishing domains at .pl, and in 80% of time our system was quicker in detection. Finally, our system helps to uncover false positives on our warning list. Even after two analysts are looking on the domains on the payload, there still are some false positives, so it helps combating this effect. Now to Michał.
So another valuable source for phishing detection domains, phishing domains detection is a DNS query stream. And our goal here is to monitor activity on DNS resolvers to detect phishing domains online. And here the major difference to what Piotr said so far is one of the major difference. is that here we switch the scope, change the scope from Poland to all over the Europe. So we target all campaigns, all phishing domains of any TLD, not just the ones targeting Poland. And what I will present now, the work, the algorithms models, or these were developed using anonymized DNS queries from DNS4EU resolvers. And it's also worth to mention that our research work is still in progress. So we use 3 major approaches for phishing domains detection. First one is based on just plain domain names. Second one focuses on correlation, dependency, or similarity between pairs or even groups of domains in time. And the last one is about using other features like autonomous system number. So let's delve into the first approach, based on the just plain domain names. So what we needed here was a model that takes a domain name as input and outputs a phishing score, so phishing likelihood score. So for benign non-phishing domains, we need a score 0 or close to 0. And for phishing domains, we want a phishing score to be 1 or close to 1. It turned out that it's even better to have 2 or maybe even more separate independent classifiers. And here we used 2 models. First is fastText. This is a natural language processing related model. And the second one is Llama, so large language model, Llama. And here we use these models to switch from domain name to a vector of meaningful numbers. And these meaningful numbers we then use for phishing classification, so to get this phishing score. Our current processing pipeline takes as input a lot of domain names, just a stream of DNS query. And to filter out at least some of them, we use several whitelists. The first one is Stranko, which is a research-oriented top sites ranking or list of 1 million, let's say, top sites, top domains. We also developed our own whitelist. So we use this DNS query stream. We analyzed it for a given period of time, let's say for 1 day. We found the most frequently queried domains, and we checked each domain for its malicious or phishing history, and whether it's possible or not to configure custom subdomain on given domain. And if not, and if the history of malicious or phishing domain subdomain is clear, we put these domains into our own whitelist. And so all these domains and subdomains of these domains are just filtered out, so considered non-phishing. And next, the domains that aren't filtered out by our whitelist. These domains are processed using fastText-based model, and domains that have this phishing score threshold higher than the given threshold are then processed using a Llama-based model. And if given domain or list of domains have the phishing score higher than the threshold for both models, then we consider these domains as phishing or possible phishing. As for time-related approach, one of the most interesting and important parameter here is co-occurrence. So co-occurrence is about finding some. So it turns out that some phishing domains, pairs or groups of domains, tend to be queried close in time by different or by given clients. So here we have 2 red domains, red phishing domains. They're queried by given clients just close in time. And what we are looking for using this red phishing anchor domains is to find maybe another domains not not listed so far as phishing, just by visualizing co-occurrence like this on the graph. So here we see these two anchor red domains and a few blue domains that look, let's say, similar, have the same TLD, maybe same name pattern. So maybe it's worth to just look closer at them. And the third approach is about using other features like autonomous system number. And so here we are working on this approach. We try to maybe be able to get some ASN reputation score, because maybe some ASN host more phishing than other, or maybe some phishing domains just switch ASN more frequently than non-phishing domains. So we are working on that approach. And as for results so far, so this is the result from our current pipeline from last Friday, the 3-hour long time window. So we got 31 million queries in total, and we filtered out using our whitelist more than half of them. The other part was processed through first fast text, then about 1 million went through the llama-based model, and we finally got about 0.5%, which is 140,000 of domains classified as phishing. But as domains tend to be queried more than once, so we got in total 31,000 of unique phishing domains for this time window. And we took a random sample of 800 elements out of this 31,000, and we checked on VirusTotal for score of these domains, and it turned out that more than half of them have already some phishing or malicious score higher than 0, including 9 in a high confidence additional phishing domains data source. So these results look promising. And we also encountered some very interesting challenges during our work. The first one is related to the training of this fast text or llama based models I mentioned before. So in our training data for these domains for these models, for two classes, non-phishing and phishing, we found out that for some TLDs like Pro, VIP, XYZ, etc., in our data set there is a huge imbalance. So we have many phishing domains in data set, but very little non-phishing. And this posed a risk that the model will just look at the TLD, so at the end of domain name, and will classify any domain under this TLD as phishing. So to prevent that, we considered either just cutting out the part of this bigger phishing dataset or group, or just duplicating the smaller one, so non-phishing, just to balance this data, these two groups, and force the model to focus not on just TLD, but the whole domain name. And the other challenge we are working on right now is how to automate the co-occurrence analysis, because these graphs look nice to me, but we need to find a way just to automate, not to look at these graphs each time, but to automate and get just list of possible phishing domains. So we are working on using our fast text llama models, maybe some TLD analysis, and the work is progress. Another challenge is dealing with a lot of streaming data. So right now we get millions or even billions of queries each day. And if we want to store some historical data for maybe some spikes in traffic detection or maybe some historical ASN data, it's very challenging to perform it online. It's also extremely hard to check and prove whether detected domains are truly phishing, because all we got here is just domain name, not a link, not a phishing link, just a domain name. So it's really hard to just verify the results. And right now we are moving to production environment.
Okay, so the third approach we are taking is monitoring DNS, monitoring DNS requests at .pl server level. We observe the traffic for newly observed domains. So the approach Michał presented is like in the picture, it's the pink looking glass, like on the level of local DNS resolver. In current approach, we look at registry level, and for the requests we are seeing them there, and we search for newly observed domains. This approach gives an advantage not given by other solutions. We can observe subdomains of domains which are not seen by, for example, certificate transparency log. We collect tuples for all DNS requests. We get the record type, fully qualified domain name, when was it first seen and last seen. So it gives an opportunity to hunt for some keywords, or some regexes, suffixes, prefixes, but also for subdomains of some specific domains. And you can link this data, connect with other systems which we use at CERT-PL. So here's an example. Main domain is hb20.pl. On our warning list, there was one subdomain, and other subdomains which were used by criminals weren't or couldn't be seen in certificate transparency logs because they have registered there only a wildcard certificate. So using our newly observed domains monitor, you can uncover other subdomains, and they could be candidates for blocking, but also it's a strong indication for blocking whole HB20 domain. So what are the lessons we have learned during our work? So if you use the registry data, you can get some good results, but only if you have a lot of phishing domains in your registry. So when the numbers went low at our registry, then the problem started. So we have to tackle them in some way. If you use the query data from Resolver, just looking at domain names gives quite good results, but it's hard to get some other features working because you have to get some dynamic behaviors and problems with some time spans, how long to observe the traffic, all those things are getting into it. The evaluation whether some threats are, or whether some domains are really phishing ones, it was already mentioned by Michał. If you haven't full URL, then you have to develop some other methods to get the proof. And finally, data from TLD servers. In our opinion, it is an underutilized source for hunting, for phishing hunting. So, you could work on it. The thing is that I think with this approach we show that not everything nowadays has to be a machine learning or AI system. Some good old approach with regexes or some keywords is working still. So yeah, good for us. Maybe AI will won't take our jobs. With this approach, we are moving to a prototype stage. So final slide showing the status of our work. So the bad domains now is feeding the DNS for EU. threat intel feed, but also our SRPL warning list. The warning list, as its own, is feeding the resolver. The next two methods, detection on the query stream and newly observed domains monitor, we believe will start to work at in this quarter, maybe at the end of the year. So it will feed domains into resolver, DNS for EU resolver, and the warning list. I ask you to visit the website of the project and our SRPL site. And that's all. Thank you.
We have time for some questions.
Very interesting talk. Thank you very much. I was wondering, especially for the ML models, how you deal with the shifting baseline problem. Did you put some thoughts into that, and which ones?
Sorry, could you...
The shifting baseline problem. So you train a model, and essentially the attackers learn that they're not successful, so they will adopt, and then your model doesn't fit their new tactics anymore.
Yeah, the model is retrained continuously on the current data. Cool. Yeah. The thing is that we are preparing a research paper, so there will be all the technicals. So,
did your question mean what they did about domains that changed after they were evaluated?
Okay, because the question, my question was about attackers generate domain names for phishing, for example, and the model trained on certain patterns on that. But once they realize it doesn't work anymore, they will try a new attempt at doing it, right? And that was basically they adapt, yeah. And that's the problem with all AI models that I see is we usually train them statically, but you answered you'd continuously train them. But if you have a static training, then, it's outdated in a year.
So now I understood your question. Thanks. Anyone else?
I think there is the one question.
Thank you so much for this talk. I have a question related actually to the models that you have used, the fast text and the Llama ones. Actually, they were made for human language before. Originally, they were meant to be used for human language analysis. And all the examples that you showed for malicious domain names, they were kind of just random strings, not like words. And my question is actually, have you noticed any patterns related to human language versus just random strings in your malicious domain names or phishing domain names?
Okay, so you ask whether we just found any other...
Whether phishing domain names are more likely to be random strings, while non-phishing domain names are more likely to be human-readable words.
Well, we see random domain names for both, unfortunately. So it's not that easy. Yeah.
Yeah, you.
Hi, I run a domain that has a virus total score, but it's legitimate. And it seems to me that everybody's compiling big lists of malicious domains and does not really care about the false positives. Have you considered how to reliably handle false positives? Thank you.
Could you ask the question once again?
Yes.
It's hard to... sorry.
So I run a domain that is listed as malicious in many places, but it's I mean, it's legitimate, I can tell you. But believe me, right?
Yeah.
But people seem to be hunting mostly for bad domains and do not really seem to care about false positives and how to clear a name. Have you considered how to handle those reliably?
Yes. In the main approach, or for the warning list, Polish warning list, there is a human analyst. So we have to make a screenshot of the website, whether there's a payload, phishing payload or not. So the other thing is with the research showed by Michał, that's the problem for us, because there we have only some prediction, and we do not have any or other information for such domain. So then that's the problem. And with using methods without any proof, we are very when we are uncertain, then we don't judge the website. So yeah.
So I have a few questions. The first one is, why fast text and Llama? I mean, clearly these two models were not trained for detecting malicious domains in general, and even so, just having what looks like a randomized string or a randomized domain, that doesn't necessarily mean that the domain is malicious per se. So how can you answer that? And the second question is, in one of the slides, you put that your model is able to detect 20% more domains than your traditional method. So I was wondering, could you share some cases? So how your model is better, basically.
So the first question is for Michał, the second one is for me, okay?
Yeah, so the first question is basically why fast text, why Llama, why large language models for classification, for analysis domain names, right? Yeah, so this is just intuition maybe. So we just needed to turn the name into numbers, right? To classify on them. So we thought that if large language models do it perfectly nowadays, so they can carry some meaning that maybe we cannot find in this randomly generated names alongside with TLD. So this was just our guess, our try to use different approaches, because fast text is not directly a large language model. It's kind of different model. So we right now use two different approaches, quite similar but still different. It turns out that they work good or work very well when paired together.
So the thing, I can extend something. So the thing is that we have 3 machine learning scientists, including Michał. They took good approaches which are working at natural language processing. Like fast text was a state of the art like 10 years ago. No, maybe it's 10 years ago. Yeah, something like that. So it was good enough. It is fast, and you can also train it on your data set. Yeah, we have done it. So that's the first thing. And the Llama, you could say that it's a state of the art currently. So yes, when we tested some other approaches, but those two gave us the most effective predictions. And regarding the second question, this presentation is TLP clear. So, my kind regards to all people who are listening to it. But if you want to some more cases, we can speak after the presentation. Okay? Thank you.
Just a small question. For Llama, I think the result depends a lot on the prompt that you give. So did you try prompt engineering, playing with different prompts? So what do you recommend in general?
We haven't yet. So we just used the Llama, like the embedding llama embedding as it is, so we don't change it. What we train is just the classifier that has this llama embedding output as input.
With the temperature turned to the max, right? You turn the temperature up to the max, so the creativity is maximized in the model, right?
Yeah. So it's
all right, so this was the TLP clear version. If you buy them beer in the bar later, they might give you the TLP amber or even maybe up to red, who knows? Let's give them a hand.